Okay, good morning, everyone. If you're just joining us for science, I posted this yesterday and hopefully got a chance to read. If you didn't, that's fine. I'm going to wait maybe another minute, see if anyone else joins us. Okay, we'll go ahead and get started. This is kind of the last lesson in Earth and space science that we've done. So it asks you to read these passages. We'll go ahead and read them together and we'll answer the questions. So passage 1, why have we not explored other solar systems even remotely through a telescope? Planets and other solar systems are too small and too far away to be seen using a telescope. However, scientists have discovered other planets in a rather ingenious way. First of all, it's not entirely true that a planet revolves around a star like our sun. While the star remains stationary, it's more correct to say they revolve around a center of mass between the two called a barycenter. A barycenter is the point which two bodies will rotate around and is determined by each body's mass and weight. The heavier the object is compared to the other, the closer the barycenter will be to it. Take a hammer, for instance. The head of the hammer often weighs more than the entire handle. The point of the balance should not be in the center, but rather close to the head of the hammer where most of the weight is. A ruler, on the other hand, would have a base center right in the middle. Scientists do the same with planets and their corresponding suns. For example, Jupiter and the sun revolve around a center of a gravity located just outside the sun. See the diagram below. As planets orbit around a star, the star will wobble because will slightly move around its barycenter. Scientists can view this wobble using telescopes, thus providing the existence of other planets outside our solar system. So number 1 says, what is the barycenter? So the barycenter would be number 1. It's the center of gravity between the star and the planet. Okay. And it says, why does the star wobble? That would be 3. The gravitational pull from orbiting planets causes it to move slightly. And the center of gravity of a hammer can be found near the head of the hammer. That's kind of the heavier point. All right. So those 3 were first 3 were just in that original passage. So you can find all the answers just right in passage 1 here. Okay. And if this were the test, I would encourage you guys to maybe read the questions first. So if you read the questions first, you know you're looking for what the barycenter is. And then number 2, it's asking you, why does a star wobble? And the third one, it's asking about the center of gravity. Okay. So we're going to go on to the next passage here. And there's going to be 4 questions that correspond to this. And this, so if we read the questions, 4 says, it asks about a magnitude of the recent earthquake in Taiwan, about how many times larger is a 9.5 earthquake compared to an 8.5, where's the largest earthquake in the US, and what was the magnitude of largest earthquake in the US. So these are about earthquakes and basically magnitudes. So right up here, passage 2. The Richter scale was created to describe the magnitude of the amount of energy released of an earthquake. The scale reads as the following. M1 to 3 record on local seismographs. And a seismograph is a machine that tracks earthquakes, how powerful they are. So if it's 1 to 3, it'll show up on the machine, but you probably won't feel it. 3 to 4, it's felt, but there's not a lot of damage. 5, felt widely, slight damage near the epicenter, and that would be the center of the earthquake. M6, damage to poorly constructed buildings and other structures within a few miles of the epicenter, some possible injuries. Okay, M7, that's a major earthquake, causes serious damages and injures people up to 60 miles away. There's been recent M7s in Taiwan, Turkey, Japan, and California. M8 is a great earthquake, great destruction, loss of life, over 700 miles. And this happened, there was an M8 in 1906 in San Francisco, and M9, that is the big daddy of them all, and that's very rare. Major damage over a large region extending 1,000 miles, extensive loss of life. The largest recorded earthquake was 9.5 in Chile in 1960, and the largest in the US was in Alaska in 1964, which was 9.2. The Richter scale is based on logarithms, so an increase of 1 is actually 10 times as powerful. An earthquake of 8 is 10 times greater than an earthquake of 7. Okay, so I just gave you some general information kind of about what the Richter scale, that's how we measure earthquakes. So if we go down to number 4, what was the magnitude of the recent earthquake in Taiwan? And if we go up to here to M7, we can see there's Taiwan. So basically, that's going to be number 3. It's going to be 7. Okay. And then how many times larger is a 9.5 earthquake than an 8.5 earthquake? So it says up here, the Richter scale is based on log. So an increase of 1 is actually 10. So that's going to be, it was 10 times, which is 3, as large. Where was the largest earthquake in the US? If we go up here, it says Alaska in 1964 was measured 9.2. So the answer would be to Alaska. And is it number 7? Oops, I went a little too far. Let me get back up there. What was the magnitude of the largest earthquake in US history? So the one in Alaska measured at 9.2. So it would be answer 4. Okay, and I think there's one more reading passage. Use the map below to answer questions 8 and 9. And this is similar to that plate tectonics thing that we did, I think it was last week. So, and you can see all these little dots are active volcanoes. And the straight lines are plate boundary lines. So if you look at this, you notice that a lot of the circles are right along those lines. So it's going to kind of be an indicator for number 8. So what conclusion can be reached from the information on the map? Volcanoes are scattered randomly across the earth? Maybe. I don't know how. Random would just be anywhere. Volcanoes are largely located at the edge of the continents. We see a lot of them are kind of in the ocean, so it's maybe not. Volcanoes are mostly located along boundaries between plates. And that's the thing I told you at the beginning, and that would be the correct answer, because you can see a lot of the circles are right along these lines, which are the boundary lines. So the answer would be 3, and we look at 4. Volcanoes are distributed equally in the northern and southern hemisphere. That would mean there's an equal, if the line went through the middle on the equator, there's equal amount in the northern hemisphere and the southern hemisphere, and that's probably not the case. I think if we look up here, you can see there's probably a little bit more in probably, I would say maybe the southern hemisphere, but they're not equal. So that one's not it. So it's going to be 3. Volcanoes are located mostly along the boundary lines, okay? And the last one, Pacific Plate is one of the world's main tectonic plates, and the Ring of Fire coincides with its plates. The Ring of Fire is created because plates push against each other. What type of plate interaction is that called? And basically, when they push against each other, that would be a convergent. That would be number 1. And if you go back and look at your last lesson, there was that one diagram that showed when arrows, when they go into each other, when they go across, or they go away from each other. And when they push against each other, that would be convergent. Okay? It's kind of like they converge on each other. So this one is rotation of the Earth. So this one shows wind curves, ocean currents, swings and change in direction, and star trails. Okay. The winds of the Earth curve, providing the Earth is rotating. Ocean currents are clockwise in the northern hemisphere and curve counterclockwise in the southern hemisphere, providing the Earth is rotating. So when the Earth is going around, you can see the winds. If you look at this diagram right here, you can see the arrows are showing the winds are basically going curved. The arrows aren't straight. And this one right here, you can see them going in circles. And there are two different ways. So in the northern hemisphere, they go clockwise. In the southern hemisphere, they go counterclockwise. So your answer might be, you would probably use the wind curve and the ocean currents. You could say that when the Earth basically is rotating, the winds are curving, and the currents basically in the northern hemisphere are going clockwise, and the southern hemisphere are going counterclockwise. Those would probably be two good examples to show the Earth is rotating, because the winds are curving and the currents also are going in directions similar to the way the Earth is rotating. Okay. And this is facts about rotation of the Earth. Rotation causes day and night, and rotation of the Earth is 23 hours, 56 minutes. That's why a day is 24 hours. The Earth is tilted 23.5 degrees, and the Earth is tilted in the direction of the North Star. And that's what that line points up towards the North Star. So it asks you, explain how evidence supports the rotation of the Earth. Basically, we talked about it. All these things basically would give you information, and I just used the wind curves and the ocean curves. Okay. So there's one more here on water pollution. All things living need water to stay alive, which is why water is our most precious natural resource. For this reason, it's important to learn about the cause of water pollution. Water pollution is simply any harmful thing that's added to water. There are many causes of water pollution, but you cannot always see what is polluting it. Water can look clear, yet still be unsafe. It can be polluted with microscopic organisms, which are so tiny they can only be seen with a microscope. These organisms are sometimes contagious and make us sick. One cause of microscopic organisms in water is sewage from pipes. Another major cause of water pollution is fertilizers farmers use to make their crops grow fast, and the pesticides used to kill bugs and rodents. When it rains, these fertilizers and pesticides can wash into our waterways. In addition, wastewater from factories contains harmful chemicals that can be poisonous to marine life. This wastewater is also very hot, and when it's pumped into waterways, it has the effect of heating up the temperature of the water. Many plants and animals cannot survive if the temperature of the water rises due to lack of oxygen. Litter also pollutes waterways. When not disposed of properly, garbage shows up on the shorelines of beaches and can be harmful to marine animals. Moreover, anything with a sharp edge can cut a mammal or fish. Marine animals are also known to mistake garbage for food. And petroleum companies ship their oil all over the world in large supertankers, but accidents do happen. An important cause of water pollution and a great loss of marine life along shorelines is accidental oil spills by these large supertankers. So it asks you the main idea, and we'll look back at this. Each paragraph kind of talks about different causes of water pollution. Okay. It's not just one thing that causes water pollution. So what is the main idea from the passage? So it gives you supertankers create the most water pollution on coastal shorelines. Maybe. There are a variety of sources of water pollution. They often are not easily seen. Maybe. Marine animals can be saved if there's less water pollution. 4, water pollution will always happen. And 5, rain causes many kinds of water pollution. I would say the main idea is there's a variety a source of water pollution, whether it be garbage, warm water, oil, litter, and they're not often easily seen because you don't necessarily see. I mean, when there's an oil spill, you see that. You really don't see wastewater going into our water, our streams and lakes. You certainly don't see those microorganisms. Pollution, sometimes you might see it, like something could be in front of ABC. Eventually that blows, maybe it gets in the Genesee River, then it gets into Lake Ontario, then eventually it makes its way to St. Lawrence Seaway, then out to Atlantic Ocean. So I think the best answer would be 2, because it talks about a variety of water pollution, and a lot of them are not easily seen. Okay. And this is just basically what we just went over. These are the answers. I went over them, but if you want to double check them, they're right there. And basically, you don't have to do this. This was just put in there as part of it. It's kind of a self-evaluation. The one thing I want you guys to take away is usually when there's a reading passage, go ahead and, I didn't do it all the time, but read the answers first so you know what you're looking for. Then go ahead and go back up and read the reading passage. Okay, that is it for science today. I'm going to be doing reading here in about 15 minutes if you want to join us. If not, have a wonderful day, and I'll talk to you guys soon. Bye. No, I don't want to live stream.